All right, guys, welcome to part 2. We're going to get into some extrema, which we're used to doing, tangent lines, pretty much that. I think that's it, actually. Oh, second derivative. We'll do integration on the third video. But anyway, you guys have done this a bunch of times. Just be careful that this is a product. So just remember to find the relative extrema, you need to find f prime of x, which means we need to do the product rule. So a times b. So first times the derivative of second. Careful, that is times -1 because it's the derivative of negative x, plus the second times the derivative of the first, which is 1, right? Okay, so we have a lot of our info already. You can factor out an e to the negative x here, so it turns into x, negative x plus 1, because of that negative sign there. Remember to set it equal to 0. You can separate now if you want to just get that out of the way. And just as a heads up, e to no power is 0. So that's a thing. When you solve the other one, you end up with x equals 1 for your critical value. Okay, so our critical number is 1. You want to plug in values on either side of your derivative. Okay, so you might want to do like f prime of x as maybe do like 0.5. I would do, just because of the way these functions work, I would do like negative or 0.5 and then like 1.5 and see what you get. All right, so hopefully you got a positive and a negative. The other reason why you don't want to go past 0 is because technically 0 is a critical value as well, but you don't have to go into the negatives. And that's mostly because of the way this function works, but you could also graph it to look at the domain. So what this means is because it's increasing and then decreasing, I have a relative max at x equals 1. But how do I find that y value? I plug it into my original. So I'm going to do 1 times e to the negative 1. So technically our y value is e to the negative 1 or 1 over e, which is 0.368-ish. Yep. Okay. So that's our relative extreme. All right. The next question is asking you to find the equation of the tangent line. Again, we've done this a bazillion times, but if you need a refresher, I will help you start it out. A reminder that to get your slope of your tangent line, you have to take the derivative of the given function, plug in the x value. Those of us who didn't know how to find the y value given an x value on your last quiz, you plug it into the original equation. So that's how they got 0. But anywho, find the derivative, plug in 1 for the x values, and you'll have your slope. All right, guys, hopefully you got for your equation for your derivative x times e to the x. Remember that you have to use product rule for the first part. But then once you do product rule and you subtract the derivative of e to the x derivative is e to the x. So the e to the x and the e to the x cancel. So that was convenient. That's your slope that you get back. So you get e, which you can just leave as e. So point slope form, this would be your answer, which is how I usually do it because it's easier. If you did slope intercept, it would be that. Okay, this one involves a little bit more because you have the ln function. Just be careful when you do the derivative of y, it's dy dx. So I'm going to have you actually try this one. You have to plug in for x and y at the end, but I'll do the workout if you're stuck so you can see how to do it. All right, guys, so this involved quite a bit, but what might help some of you to do at the beginning is actually to rewrite the original problem as 1 plus ln of x plus ln of y. Remember, you can do that with the properties of logs. The other thing to remember is when you take the derivative of ln of y, it becomes 1 over y times the derivative of y, which is dy dx, okay? Same thing with this. You have to use e to the x minus y times the derivative of that exponent, which is 1 minus dy dx. So I moved things around. I distributed the e to the x minus y, and then I got dy dx by itself. So if you need to follow through with that, you can. And then your final step, I wouldn't even simplify this completely. So this would be your final dy dx. So plug in your 1 and your 0. Or sorry, your 1 and your 1 for x and y. So you end up with 0 over 2, which is 0. So your slope is 0, which is actually kind of nice because then your equation is y minus 1 equals 0 times x minus 1, which is literally just y equals 1. That's your equation. So it's actually a horizontal line. Alrighty, folks, this is your last question for these notes. So find the second derivative. Because I know you know how to find the second derivative, I'm going to have you try this. But that means, remember, you want to find the first derivative and then take the derivative of that to get the second derivative. So I'll pause, try it out, and then when you're done, hopefully you'll have it right. Alright, folks, check your first derivative first because that's going to help you make sure you have your second. I rewrote the equation 2 as x to the 1/2 first just to make my life easier, but just be careful, you have to use the product rule here. So it's first times the derivative of the second plus the second times the derivative of the first. So that means that you're going to have to do product rule twice for your second derivative, hence why I needed 2 lines. So my second derivative involved the derivative of this part first, after obviously the front you guys can do, but this is literally the whole derivative of that part, and then you have to do the derivative of this, which is here. So to clean it up a little bit, you end up with negative 1 over 4x to the 3/2, because you don't want those negative exponents. If you want to write it as a radical, that's fine too. It would be negative 1 over 4 square root of x cubed. And then the next part you want to do, you could turn this into subtraction. Because there's a negative here, so you throw it out in front if you want. So it'd be minus e to the x over x squared. And then you could do plus, actually there's 2 of those, so that's kind of nice. So it's plus 2 e to the x over x, and then plus ln of x e to the x, or put the e to the x first, this doesn't really matter. But that would be your final. It looks gross, but that's it. Alright guys, enjoy the rest of your day. See you later.